Hey guys, and welcome back to Mr. Cole's class. So we've got another example of us balancing equations. This is like, I think, video 3 or 4 in this series since we started looking at this. And first off, this is kind of cool. Let's do this. What kind of reaction is this? There are two reactants and one product. Hopefully, before I could write this, you wrote, well, it's a synthesis reaction. All right, cool. So now let's actually go and balance this equation. So I'm going to draw my T on here, one random mark from where my finger hit the screen. And let's see what we got. We got Fe, we've got oxygen, and so we should have the same things on the other side. So I'm going to make this my T, as I call it, and it's just a little graphic organizer that helps me do these. So now let's count. I've got one iron on the left. I've got two oxygens on the left. I've got, what else? Two irons on the right and three oxygens on the right. All right, so that's pretty awesome. So now as I go through and try and figure this out, let's start trying to balance this one. All right, now I gave you a hint last time. When you're trying to balance, start with the one that shows up the least. Well, let's see. I see iron twice and oxygen twice. Mr. Cole, your advice, as usual, is useless. Well, this happens sometimes. So here's another hint. If, for example, you get in this situation and you decide, hey, I'll pick iron to start first. Eeny, meeny, miny, mo. If you pick iron and the problem becomes a pain in your buttocks, Mr. Forrest Gump, then start over. This time go all the way back to here, start completely over, undo everything that you've done, start over, start with oxygen, and you'll find a lot of times the problem was really very easy. So that's a good little hint to do if you pick one to start and it becomes a pain. So which one do you want to start with? Well, I got an idea. Let's start with oxygen. Because when I see 3 and 2, the first thing that comes to my mind is the number 6. So if I look at this, what could I multiply oxygen by to have 6? Well, I can multiply by 2. So what somebody will do is they'll walk up here and they'll jam the number 2 in the middle of that formula. Well, hopefully that looks completely dumb and insane to you. So erase the 2. I want to multiply the 3 by 2, but I can't jam it in. I have to go all the way to the front of the formula, and I have very little room here. That's why I said usually I like to leave a lot of room in these. And so now that 2 multiplies by the 3, and it gives me 6. Yes! Here's where somebody will goof up. They forget that when you multiply the 2 by the 3, it's also multiplying this iron. So that's also 2 times 2 irons. And you're like, great, Mr. Cole, you're trying to fix O, and you've only made it worse. Now you've jacked up Fe. Well, stop worrying about it. We'll get there in a second. So let's go back to the oxygen. Finish our thought. If I wanted 6, then what can I multiply this 2 by? Well, that's easy. 3 times 2 gives me 6. Hooray, I've fixed the oxygen. Well, but now the iron's messed up. I've got 2 times 2, I've got 4 over here and only 1 over here. Well, it's easy. Multiply this times 4. 4 times the 1 Fe is 4, and bam. Thank you very much. This is a balanced equation. Now, the thing is, there's usually more than one way to work these. So let's do something. Let's go back and let's try and start this one with the iron first, because there's always more than one right answer to these. At least that's what I'm going to keep saying. So how about this? Let's start with the iron first. There's 2 irons on the left and, there's 2 irons on the right and 1 on the left. Well, let's do this. That 3's driving me crazy. Let's do this. Let's put a 2 in front of the Fe. Well, 2 times 1 is 2, and now we balance the Fe. And now you should be like, all right, well, Mr. Cole, what are we going to do to try and get this 3 to balance? We got 2 here, 3 here. Easy. And this is why I wanted to do this. Here's my question. What can I multiply by the number 2 in order to get the number 3? Well, I'll give you a hint. This is essentially algebra. 2x equals 3. So that means, what is x? 3 halves. Or in this case, 1 1/2. However you want to work it out. But the deal is that 1 1/2 times 2 is equal to 3. So I could jam the number 1 1/2 into this space. 1 1/2 times 2 is equal to 3. And guess what balances? Or you could go back and you could go with the 3 halves. I don't care. Mr. Cole, I've got a teacher, though, that won't let me use fractions when I balance equations. Cool. So multiply everything times 2 in this thing. So we go across. 2 times 2 is 4. 2 times 3/2 is 3. And 2 times the other side is 2. And you're like, wait a minute. That is the exact same answer we had last time. Yes, I know. That's why the fraction thing still works. All right, so moving on. Again, I get why they don't want that, because you can't have 1.5 oxygen atoms in a problem. So I get this keeping everything whole numbers, but the fact is, again, we use this later for stoichiometry. It still works fine. Next problem. So let's check this one out. Let's go ahead. Let's do our T. And each of these problems I've picked for a reason. So we've got chlorine, we've got lithium, and we've got iodine. Now, interesting question. Chlorine, lithium, and iodine. What kind of reaction is this? Somebody's going to look at this and say it's kind of like compound. Well, you're technically not wrong, because this is Cl2. But I view this as just Cl. So in my mind, that's just an element. And then here's this compound, this made up of, because this is actually a diatomic molecule, is all it is. So we got this chlorine. It's probably a gas. You'd see a G written beside it in some book. So there's a compound. Sorry, a little burp for you. And that's disgusting, I tell you what. What are you expecting for free education? And then this one over here, then this is essentially another element as well, which tells me this is a single replacement reaction is what it is. If you look, all that's happened, the chlorine and the iodine are taking place. Now, somebody might be looking at this going, well, Mr. Cole, how come it's not Cl and I on the other side? Well, remember oxidation numbers. Chlorine is a -1. Now, it's bonded here as a molecule. It's covalent. Lithium is a +1, iodine is a -1. So we're not going to have Cl and I bonded together, because on the other side, we're going to have this +1, -1, and then we know that iodine is a -1. We can't have Cl -1 and I -1 bonded together. They're both trying to take electrons. Now, we could try and do some crazy covalent deal here, but that's not what we're going to do, and especially not for this basic class. By the way, if you're looking at this going, Mr. Cole, I have no idea about these pluses and minuses, you need to go back and watch some videos on nomenclature and chemical bonding and all that kind of stuff, ionic bonding and covalent bonding. So let's do this. Let's get right to our counting at this point. So let's go. I'm going to pick the color blue. I've got 2 chlorines on the left. I've got 1 lithium and 1 iodine. I've got 1 chlorine on the right. I've got 1 lithium on the right and 2 iodines. Now, there's 2 ways, like normal, we can balance this one. One, I can just say, let's try and balance the chlorine. So if I've got 1 on the right, then multiply by 2. 2 times 1 lithium, because you got to do the lithium and the chlorine. 2 times 1 lithium is 2. 2 times 1 chlorine is 2. Cool. I fixed the lithium, or the chlorine, but in the process messed up lithium. Fine. So let's go fix the lithium over here. I need 2. So jam a 2 in there. 2 times 1 lithium is 2. 2 times 1 iodine is 2. And, oh my goodness, look at what's happened. 2, 2. 2, 2, 2, 2. I have balanced this question. Wow, that was easy. Well, Mr. Cole, you said there's another way. Yeah, there's always more than one way. So let's go back to the beginning again. How else could we have balanced this problem? Easy. I've got 2 chlorines on the right, or on the left. As soon as I learn left from right, this video will get better. I've got 2 chlorines on the left and 1 chlorine on the right. So just do this. Get rid of that 4. It's driving me crazy. Half your chlorine. What is half of Cl2? Well, it's 1, so I balance that. Go to the other side. This 2 and 1. Half the iodine on the other side, and look at what you've got. What's half of 2? 1. Mr. Cole, my teacher won't let me use the fraction. Well, fine. Multiply everything by 2. It cancels that, gives you a 2 there, and cancels that, which was the answer we had last time. So that's why they're the same answer. Let's do one more. And this will be the last one. This one should be a little bit of a good one. So right off the bat, this is going to be double replacement. I've got a compound and a compound. So, and I left this one for us to kind of finish out. You need to look up your oxidation numbers. That's a +3. Nitrate is a -1. Hydrogen is a +1. Sulfate is a -2. And that's why we've got these additional subscripts balancing all this out. So on the other side, I'm going to leave some room. I'm going to have Al, which is still a +3. And now on the other side, that's going to trade places with the hydrogen. So it's going to pick up the SO4. And I'll balance out my pluses and minuses in a second. Sulfate's a -2. Plus now the hydrogen, which again is +1, is now with the NO3. And somebody will be tempted to bring the NO3 over here. Please don't. It's NO3 because it's trying to balance the pluses and the minuses. NO3 is a -1. So now let's balance out our pluses and minuses. I've got 3 and 2, so I need 2 aluminums and 3 sulfates is what I need. And then, hey, cool, +1, -1. This one's already balanced out. So now let's go straight for doing my T. I'm going to draw the biggest T I've ever drawn ever, just making it massive because it doesn't matter. Some of you are much neater than me, I'm sure. Write down your elements. I've got aluminum. I should not write capital L. How extremely childish of me. I've got aluminum. I've got nitrogen. I've got oxygen. I've got hydrogen. And now I've got sulfur. And I've got oxygen again, which I've already got. Cool. So I've got aluminum, nitrogen, oxygen, hydrogen, and sulfur. All right, so begin your count. I've got 1 Al. Let's do this. Let's change colors at this point because I think that'll be beneficial. Green. I don't use green a lot. I've got 1 aluminum. Nitrogen, I've got what? Well, it looks like 1, but it's in parentheses, so it's really 3 times 1. So there's 3 nitrogens. I've got, now this is where we're going to lose count. 3 times 3, I've got 9 oxygens here and 4 oxygens here, so I've got 13. Well, that's not a good sign, 13 oxygens. Hydrogens, I've got 2. And sulfurs, I've got 1. All right, let's go to the right side. Aluminums, I've got 2 aluminums. I've got 1 nitrogen. Oxygen, 3 times 4 is 12, plus the 3, that's 15. Hydrogens, I've got, well, 1. That's easy enough. Sulfurs, I've got, what we got here? 3 times 1 is 3 sulfurs. So now you're going, all right, so which one am I going to start with? Oh, my goodness. All of them are unbalanced. Aha. Mr. Cole gave me a trick. He said, start with the one that shows up the least. Let's pick pink. Hopefully nobody's colorblind. I see aluminum twice. Wow, that is a terrible color to be writing with. Let's go with like an orange maybe. I see aluminum twice. I see nitrogen twice. I see the letter O 1, 2, 3, and 4 times. So I see 4 oxygens in this problem. How many times do you see the letter H? Well, let's look. There's 1 and 2. How many times do you see the letter S? 1 and 2. All right, Mr. Cole, your trick. All you have actually kind of done for me here, Mr. Cole, is done this. You've let me know that I do not want to try and balance oxygen first. So now I'm going to ignore oxygen, and I need to know, so which one of these am I going to try and pick? Well, I'll give you a hint. It's eeny, meeny, miny, mo again. Pick whichever one you want to try. Aluminum, nitrogen, hydrogen, sulfur. Just don't pick the oxygen. And other advice. Let's say that you pick nitrogen and this problem becomes a pain in your butt. So in other words, you look and go 3 and 1. So your first move is to put the number 3 over there. Well, I'll go ahead and tell you something. If you pick nitrogen to work this one, because I've already worked it, it becomes a pain in the butt. You'll probably start over. So I'm going to get rid of that 3. So how about this? I'm going to start with aluminum because it's first. And plus I know that it works if I do that. So let's start this off. Number 5, go away from me. That's driving me crazy. So let's do something. Let's put the number 2 out in front of that aluminum. But now that balances the aluminum. But now look at this mess. 2 times 1 aluminum is the number 2. Cool. Now, here's the deal. This is not 1 nitrogen. This is really 3 nitrogens. So 3 times 1 is 3. 3 times 2 is now 6 nitrogens. That's why I didn't want to start with the nitrogen. So now check this out. 3 times 3 is 9. 9 times 2 is 18. You're killing me, Mr. Cole. I sometimes write like a little note under it like that. 18 and 4, because we're adding up the whole side. So get this. 3 times 3 is 9. 9 times 2 is 18. So this is 18 plus 4. And what have we got? That's a total oxygen now of 22, but I'm not going to worry about that. All right, so now, which one do I try and balance next? Well, let's pick nitrogen now because it's next. I'm just kind of going in the order. I got lucky here. So if I got 6 on the left, what can I multiply the right side by to get 6? Well, let's go with 6. But let's do it in order. I don't want to get messed up here. When I put that 6 there, that 6 times 1H gives me 6 H's. 6 times 1 N gives me 6 N's. 6 times 3 gives me 18 oxygens. But now when I look on the other side, holy cow, 3 times 4 is 12. 12 and 18, Mr. Cole, you're going crazy. You've got 30 now. It's okay. We'll just keep going. So, all right, we've got everything worked till now. So now OH and S, hey, Oxford High School. OH and S is all unbalanced. So which one do we want to do? Let's just do this. Let's do hydrogen. I know I don't want to worry about oxygen. There's 3 hydrogens on the right, there's 6 hydrogens on the right, 2 on the left. So let's do something. Let's go up here and let's add the number 3. Coefficient 3. 3 times 2 is 6 hydrogens. 3 times 1 sulfur is 3 sulfurs. Hey, look, we just fixed sulfur and weren't even trying. Now check this out. 3 times 4 oxygens is 12. But don't forget, we had 3 times 3 is 9 times 2 is 18. Wait a minute. 18 and 12 is 30. And we balance the oxygen without even trying. See, that's the method to the madness, is in the end we fix the oxygen, we didn't even try. All right, I'll post like one more video with a few of these that are like really hard, but the goal is by now you should be able to go. We never wrote what this one was. It was a double replacement reaction, compound, 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 compound. And so hopefully you're off to a good start, and we'll talk to you later. Thanks.